So today we're looking at the problem sum of digit differences of all pairs from weekly contest 398. So the question reads that we're given an array nums consisting of positive integers where all integers have the same number of digits. This is a big hint that we should keep in mind. The digit difference between two integers is the count of different digits that are in the same position in the two integers. We want to return the sum of the digit differences between all pairs of integers in nums. So let's look at this example. So the digit difference between 13 and 23 is 1. So how do we get this exactly? So let's take 13 and 23. We see that in this first spot, these are different, so we can add 1 here, but 3 and 3 are the same. This is 0. Another example is 23 and 12, right? These are different here, so we add 1. These are different here, we add 1. So it doesn't matter that we have two 2's because these are not in the same position, right? What we're really doing is checking each spot and seeing how many other elements is this number different than. So let's look at an example a little bit closer. So we have 13, 23, and 12. So we already kind of saw before that one way we might think about doing this is to iterate through each position of these numbers, right? And we're able to do this because our numbers, even though they will be large, up to 10 to the 9, we're iterating not through all the values in this range, but the digits, right? So if we have 10 to the 9, some number of zeros, we're really only be going through like 10 digits for each number. So this is something we could actually do, and it won't be that costly in terms of time complexity. So let's think of what we would even do iterating through these digits, right? So maybe one thing we can do is keep a count. So let's first go through the first digit of all these numbers. So we'll see 1, we have a count of 1, okay? Nothing we can really do at this point. So let's say 2, now we have 2. So is there anything that we can do with this information? Well, we see that we have a 2 and a 1 in the same position, right? So here we know that this 2 and this 1, we can make a pair out of this. So what we could do is say, iterate through every other key. Say we had 1, we had 3, we had 4. We could take, all these counts here. Let's see, there's some counts here, and we can add these to our pairs, right? And why can we do this? So we see we have one other 1 in this position, so this 2 can pair with that 1, 1. We have 3 other 3's in this position, so this 2 can pair with all 3 of those 3's. Likewise, we have 2 4's in this position, so that 2 can pair with all those other 4's. So essentially what we're doing is saying, what other elements that are not the same as this element have we seen so far? So we could iterate through all the keys. We could also keep a count, right? It's a count of the total number of elements that we have. So here we have 2, and we can just subtract out how many occurrences of the current element that we have. And we do this because we know we can't make pairs with these current elements because they have to be different, right? So when we're adding a 2, we could say, okay, we could add 2 minus 1 equals 1 to our total. Let's again move on to 1. Our count now becomes 3. We have 2 1's. And we know that with this 1, we can add 3 minus 2, 1 pair. And see, all I'm doing here is taking whatever the current total is and subtracting out the count of the current element that we're looking at. And essentially, we just do this for every position, right? So now we're going to start with a new hash map, right? Because we only want to know what we've seen in this position and not previous. So we'll have a new hash map. We'll have 3, 1, another 3. So this becomes 2. And then we're going to look at this 2. So we'll add our 2. Our total is 3. But we know that we can add this total minus counts other than ourselves. We subtract out 1, we get 2. So then our total is 4, right? So essentially what we're doing here is just saying, iterate through every position for all these numbers, and then we're going to look at what's different by keeping track of the frequencies and just add that to our total. So the time complexity of here is just O of n, right? Technically, we could do O of n times 10 because for each spot in n, we're going to iterate through up to 10 digits. However, constants cancel out, so this will end up just being an O of n solution. So let's hop over to the code and show you exactly how this works. So the first thing we do here is just instantiate this variable total pairs. And what this does is just keep track of the pairs that we've seen, and this is what we're going to return as our final answer. So then what we're going to do is start this for loop, and what this does is it's going to iterate through all the positions for each number. So we're taking this first number, getting its length, and saying we're going to iterate through every position in this number and use this to iterate through all the numbers. So then for this position, we're going to say, so far we've seen 0, but we're going to increment this as we have seen digits. And we're going to also keep a hash map of our digits that we've seen so far. So then go through each number, we're going to convert the number to a string and get that digit. Then what we do is add to total pairs the count, this being the total count of digits that we've seen in this position, minus the number of the count of the digits of the same digit, right? So what we're doing is saying we can make a pair with every other element in this position besides the one that are the same as what we have now. Then what we do is we just add 1 to our count to say that we've seen another element, we've processed 1 more, and then also add the count of that digit that we're currently looking at into our hash map. Then once you go through all that, we just return the total pairs. So let's submit this and make sure that it works. And it does. So hopefully this is helpful, and thank you for watching.